Hello and welcome back to this video series about the Intermediate Math League of Eastern Massachusetts. Today we're continuing on with the arithmetic section for Me Too. We're going to talk a little bit about decimals and then how decimals and fractions can be used together. So let's get right into it. Right, so as I said, first we're going to be talking about decimals. So decimals are the other way of writing a portion of a whole number, which aside from fractions is the only other way. So some examples of decimals I have here are 0.25, 0.8, 4.5, and 0.3 bar. So decimals can be a little bit more complicated than fractions, but don't worry, I'll get into exactly what each of these mean in just a second, especially this last one, which might be a little bit confusing. So first, just to talk a little bit about how decimals work. Here I have an example of a big number with a big decimal in it. So this number reads 745.345. And when it comes to the decimal, you just read it as point and then whatever the numbers after it are. So in a decimal, you always have what we call the decimal point. And this represents that everything after this decimal point, which is part of the decimal, so the 345, is less than the value of 1. So this 0.345 is less than the value of 1. And if you're confused about what that means, I think I'll be able to explain it when I explain how the place values work. So in a number like 745.345, there are place values for each number. This 5 is in the ones place. This 4 is in the tens place. This might be familiar to you, and this 7 is in the hundreds place, because it represents 745. 7 hundreds, 4 tens, and 5 ones. So this 7 is in the hundreds place, the 4 is in the tens place, and the 5 is in the ones place. Now, just like whole numbers have place values, decimals also have place values. So this 3, which is part of the decimal because it comes after the decimal point, is in the tenths place. And if you know what a tenth is, it means 1 over 10, 1/10. So this 3 would represent 3 tenths. This 4 is in the hundredths place. Notice how I said hundredths and not hundreds, because it represents 4 1 over 100, right? So this 4 represents that we have 4 over 100. And then this 5 is in the thousandths place, or in the place value of 1 over 1,000. So the 5 represents that we have 5 1 over 1,000ths, which means we have 5 thousandths total. So what this decimal represents, and notice how I just made 3 fractions out of this decimal here, is 3 tenths and 4 hundredths and 5 thousandths. And now if I make them all have the same denominator, which you should remember from the last arithmetic lesson, so if I make them all have the same denominator, which I'm going to do, by just adding 2 zeros to the 3 and the 10, adding 1 0 to the 4 and the 100, now they're all over 1,000, then this represents 345 1,000ths. So this decimal, 0.345, represents 345 1,000ths of a number. And obviously this fraction can be simplified, but I wanted to show you, show it to you in this form, so you really understood exactly that this represents either tenths, thousandths, 100ths, 10,000ths of a number, and so on, based on how many decimal points you have. Each decimal has a place value. So you have the tenths place, the hundredths place, the thousandths place, and then after that would be 10,000ths, 100,000ths, and so on. So that's what decimals mean. Now, decimals can be broken up actually into 2 different categories. In the example I just explained to you, more applies to the first category, which is terminating decimals. So terminating decimals are just decimals that end. They don't repeat on after whatever decimal you have here. So in this example, I have 0.3, 0.4, 0.25, and 0.9. All of these decimals just end. This one ends at the 3, this one at the 4, this one at the 5, and this one at the 9. And they don't go on after that. So that's what we call a terminating decimal. And these are the ones that you can just put over 1,000. So this would be, or put over whatever tens value you have. So this one would be 3 tenths. The next one would be 4 tenths because it's in the tenths place. The next one would be 25 100ths because the 5 is in the 100ths place. And then the last one would be 9/10. Now, the reason that this doesn't really apply to the next category, which is repeating decimals, is because these decimals actually go on forever. So this 0.3 bar, and this is how we say it because it has a bar on the top of it, this represents that the 3 repeats on forever. So it's 0. So what this really means, 0.3 bar, it means 0.33333, and so on, right? Oops, that's not a 3. Okay, 3 and so on. And this repeats on forever. So if you're figuring out what power of 10 to put this over, like, this one we had 3/10. Well, there's no value you can do because it just repeats on forever. So you'd have an infinite amount of zeros, right? So that's where these decimals are a little bit different. And don't worry, I'll get into how to convert these into fractions soon. But what this one means, 0.4 bar, is 0.444, and so on. And then 0.142857 bar, which might seem a little random, but this is actually a really common repeating decimal. This means 0.142857, 142857, and so on. And so now just a little note about repeating decimals. Now it does matter where the bar is. So I have some examples here. So in this example, I have 0.34, the bar above the 4, and then 0.34 bar, with the bar above the 3/4. Now these two are actually completely different decimals because the bar represents which numbers repeat. So in the first example, 0.34 with the bar over the 4, it just represents that the 4 is the only number that repeats at the end. So it'd be 0.344444, and the 4 goes on forever. In this second example, since the bar is above both the 3 and the 4, then both the 3 and the 4 repeat. So it's 0.343434, and so on. And so you have to make sure you know which decimals the bar is above, because the only ones that the bar is above are the only ones that repeat. All right, so next we're going to be talking about how fractions and decimals can relate to each other, and specifically how fractions can be converted into decimals. So if you remember, a fraction really just represents one number being divided by another. So in this example, I have 3/4, but what this really represents is 3 being divided by 4, which is not a whole number, which is why we write it as a fraction. So therefore, if I were to try and convert it into a decimal, just like I divide any other numbers, I actually have to divide 3 by 4. And the way you do this is with long division. So you use long division to convert fractions into decimals. And this is where it gets a little bit confusing, because I bet a lot of you already know how to use long division, but you probably don't know how to turn fractions or remainders into decimals using it. So here I'm going to show you exactly how to do that with long division. And if you don't know long division, I really, really recommend learning it, because otherwise you're not going to understand what I'm about to teach you. And you're probably not going to understand how to convert fractions into decimals, because this is easily the best way to do it. So I have 3 divided by 4 here. So on the inside, I put a 3, and on the outside, I put a 4. Because it's 3 divided by 4. So normally with long division, you say, okay, how many times does 4 go into 3? And then you'd realize it goes into it 0 times. So on the top, I'd write a 0 here. And since there's nothing left to bring down or nothing left to divide by, this is where most people will be done their problem. You'd say 0 with a remainder of 3. Well, that's not what we're going to do. We're actually going to continue the problem on from there. And the way you do that is the only way you can divide by a number with long division is if you have an extra number to divide by. So we had a 3, and there's nothing else after that 3 to keep dividing by. So what you have to do is you have to add a number after the 3 to keep dividing. And you can't just add any number. Specifically, you have to add a 0. So if I add a 0 onto the end of the 3, now I'm dividing 30 by 4. But if you divided 30 by 4, then you get a number above 1, which is why in your answer you want to add a decimal point. So this is how it works. You keep adding zeros when you have nothing left to divide by, and in your answer, when you start adding those zeros, you put a decimal point. So 0, because I divided 3 by 4, point because I started adding zeros, and then I keep dividing with my long division. So now if I were to do this question, 30 divided by 4, well, I get 7 here because 7 times 4 leaves me with 28. And if I subtract 28 from 30, that leaves me with 2 at the bottom. Okay, well now I bring down the next number, but I actually don't have one. So what I have to do is I have to add another 0 onto the end. So now I can bring down the 0, and that gives me 20. 4 goes into 20 5 different times. So 5 times 4 leaves me with 20. And if I subtract 20 minus 20, that gives me 0. And then with long division, you always know that if you get 0 at the end, that means you finished the long division question. So I don't have to add any more zeros onto the end because there's nothing else to bring down. I just have 0 at the bottom. So my answer then would be 0.75, because remember, I added this decimal point when I started adding zeros right here. So since I got 7 and then added another 0, brought it down, divided by 20 by 4, and I had 5, then my answer, 3 divided by 4, is 0.75. And then what that really means is 3/4, my fraction, equals 0.75 when it's converted into decimal form. All right, I'm actually going to do one more question, and this one's going to be a little bit different, and you'll see why when I get a little farther into it. So the decimal, or the fraction I'm going to be converting into a decimal this time is 5 divided by 11, or 5/11. So I'm going to do the exact same thing. I'm going to set up my long division question. So first I make my box. On the inside, I'm going to put 5, because 5 is being divided by 11. And on the outside, I put 11. All right, so we're going to use the exact same strategy. 11 goes into 5 0 times. So I put 0 here, and there's nothing left at the end. So instead of just saying 0 remainder 5, what I do is I add a 0 here, and I add a decimal point in my answer. So now 11 goes into 50 4 times, right? Because 4 times 11 gives me 44. So if I subtract 50 minus 44, that leaves me with 6. Okay, all is still good. So I have to add another 0 so I can bring down another number. So I bring down the 0, and that gives me 60 divided by 11. Okay, so 60 divided by 11 gives me 5, because 5 times 11 is 55. And if I subtract 60 minus 55, then you get 5, okay? Well, now I need to bring down another number. So I add another 0, and I bring that down. And so 11 goes into 50 4 times. So 4 times 11 gives me 44. And I'm still not done because I don't have a 0 at the bottom. So I do 6, I add another 0, and I bring it down. And by now you should be noticing a little pattern. If I keep doing this, I'm actually never going to finish, because if I divide 60 by 11, I get another 5 at the end. I get 55, and that subtracts to another 5. And this is really where you should be noticing this pattern. If you noticed exactly what numbers I've been dividing by, and exactly what numbers I'm bringing down, you're going to notice I just keep doing the same thing over and over again. I started by dividing 50 by 11 because I added a 0 onto the end of a 5, and then I did 50 divided by 11, which was fine because I got 44 and then got left with 6. So next I divided 60 by 11 because I had a 0 on the end, and that gave me 55, so I subtracted, and now I have a 5 at the end. And then when I brought down the 0, I have another 50 here. Well, if I'm dividing 50 by 11 again, and I just keep adding zeros on the end here, remember these zeros could go on forever. Well, if I'm dividing 50 by 11 again, isn't that going to leave me with the exact same answer I had before? A 6, and then a 5, and then a 6, and a 5, and 6, and a 5, and so on. So the long division question actually never ends because it repeats on forever, and you're going to get a repeating decimal. And if you kept dividing, you get 0.45, 45, 45, 45, and so on. And when you notice this in a long division question, that you're doing the same calculations over and over, which is 50 divided by 11 and then 60 divided by 11 over and over again, that means you've actually finished the question because you have a repeating decimal at the end. So here, since 4 and 5 repeat on again and again, then my decimal would be 0.45 bar. with the bar over both the 4 and the 5, because this means it repeats on forever. So 5/11ths would be equal to 0.45 bar. And so you just have to make sure that if you're not getting a 0 at the end when you subtract, but you're getting the same numbers over and over, which are 50 and 60 in this case, then that's when you've actually finished the question. All right, so now I have a practice question with converting a fraction into a decimal, which is what is 1/7 written as a decimal. If you'd like to try it, I'll give you a few seconds to pause the video and then I'll explain the answer. So the correct answer to this question was 0.142857 bar, with a bar above the entire thing. All right, so if I get into this question, like any fraction decimal conversion or fraction to decimal conversion, I have to use long division. So if I write out a 1 on the inside and a 7 on the outside, now I'm dividing 1 by 7. So naturally, 7 goes into 1 0 times. So I put a 0 at the top. And then since I have no numbers left, I have to add a 0 at the end of the 1 because I'm doing a decimal. And then I add my decimal point in my answer. All right, so 10 divided by 7 leaves me with 1 because 1 times 7 gives me 7. And then if I subtract that, that leaves me with 3. So now I have to add a 0 at the end again because I don't have any more numbers to bring down. So if I bring down that 0, that gives me 30 at the bottom. So 7 goes into 30 4 times because 4 times 7 is 28. So if I subtract 28 from 30, then that gives me 2. All right, so add another 0 at the end so I can bring down another number. So I have 20 here. 7 goes into 20 2 times because 2 times 7 is 14. 3 times 7 is 21, which is why it's only 2 times. So if I subtract that, then that gives me 6. So now I have to add another 0 at the end to bring down another number. And sometimes this can be a little bit tedious because sometimes you will have pretty long repeating decimals. So 7 goes into 60 8 times because 8 times 7 is 56. All right, so if I subtract 56, that leaves me with 4. And really here, when you get past 4 decimal points, you should be looking to see whether or not you're starting to repeat divisions by the same number. So first I divided by 10, or divided 10, then 30, 20, 40, 60, and now I'm on 40. Okay, so I haven't repeated anything yet. So I keep going with my question. 7 goes into 40 5 times because 5 times 7 is 35. So if I write 35 here and subtract that, I'll have to write a little bit smaller so I don't get to the bottom of the screen. So 40 minus 35 is 5. All right, now I'm dividing by 50 because I have to add another 0 and bring another 0 down. All right, so I'm dividing by 50. I haven't divided by 50 yet, so I haven't repeated anything yet. 7 goes into 50 7 times because 7 times 7 is 49. All right, so 49. And then if I subtract that, that leaves me with 1. And then if I bring down another 0, and this is where you should notice I just started repeating numbers. Because remember, first I started by dividing by 10. And now I divided by 30, 20, 60, 40, 50. And I'm back to 10 again. And if you really want to confirm, you can divide 10 by 7, which will give you 1 because you add another 1 at the end. Then you do 7 at the bottom. And I'm moving here just because I don't have enough room. 10 minus 7 is 3, and if you were to bring down another 0, which would be here, you get 30. And in fact, that does confirm that you are repeating exactly what numbers you're dividing by. So first you divide by 10, 30, 20, 60, 40, 50, and then you repeat 10, 30, 20, 60, 40, 50, which means your answer is going to keep repeating as well. 1, 4, 2, 8, 5, 7, which means since the 1, 4, 2, 8, 5, 7 repeats, then this is where you put the bar. So your final answer should be 0.142857 bar. And I know that this repeating decimal for 1/7 is pretty obscure, but this actually might be one that you want to memorize because 1/7 comes up in a lot of questions because it's an obscure repeating decimal. IMLEM likes to give you tough questions where you have to do lots of long division to try and find what the repeating decimal is. So if you just have this one memorized, I promise it'll save you on at least one question a bunch of time. All right, so now we're going to be talking about converting decimals to fractions, or going the other way. And I decided to talk about a second because it's a little bit more complicated. So there's actually two different key concepts that you need to know. And one of them I didn't write down because we already actually learned it. Because there are different ways to convert terminating decimals and repeating decimals into fractions. So just to review terminating decimals, remember when you have a terminating decimal, like for example 0.382, you have different place values for each of the numbers. So the 3 is in the tenths place, so this is the tenths. The 8 is in the hundredths place, and the 2 is in the thousandths place. So what this means is 3 tenths, 8 100ths, and 2 thousandths. And so if you actually made that into a fraction and added them and simplified them so you could actually add it, it would be 382 1,000ths. And so that's how it works with any terminating decimal. You figure out how many decimals there are in the decimal. So you have 3 different ones here because there's 3, 8, and 2. And then you put that over a number with that many zeros and a 1 at the beginning. So since 1,000 is 3 zeros, I divide it by 1,000. If I had a different number, like for example, 0.75, remember this is the one that equals 3/4. Well, since I have 2 decimals here, 7 and 5, I put it over a number with 2 zeros that starts with a 1, which is 100. So 0.75 equals 75 100ths. And then obviously, since that's my fraction, I could simplify it from there. If I just divide both the numerator and denominator by 25 to simplify, since they have a common factor of 25, well, 75 divided by 25 is 3, 100 divided by 25 is 4, so that would give me 3/4 as 0.75, which we already learned when we converted 3/4 into a decimal. Now, if you're confused on what I was doing with those fractions, I explained it in the first arithmetic video for me too, so I'd recommend watching that if you're confused how to simplify fractions. Okay, so now converting converting fractions into repeating decimals is a little bit harder because the same concept, while it still applies, you can't actually use it. And the reason why is because if you think about what a repeating decimal means, so here I have 0.11111 whatever, right? So if I had 0.111 and this repeats on forever, well, remember what I said, you want to put it over a number with as many zeros as you have decimals. But this has an infinite amount of decimals because the 1 repeats on forever. So if you're to try and put that over a number with that many zeros, you'd also have an infinite amount of zeros in the denominator, which would make it impossible to simplify, and that's why that concept doesn't work. So instead, we have to use another concept. And that concept is by using fractions of ninths, 99ths, 999ths, and so on. So if I look at 1/9, 1/99th, and 1/999th as decimals, well, 1/9 is 0.1 bar. 1/99th is 0.01 bar. 1/999th is 0.001 bar. And you can imagine I could continue this on, like 1/9999th would be 0.0001 bar. And that would just continue on forever with all the different fractions with only 9s in the denominator. So what does this mean when it comes to converting decimals into fractions? Well, you can reverse it the other way, because if 0.1 bar equals 1/9, then shouldn't 0.2 bar equal 2/9? And 0.3 bar equals 3/9, right? And if I look at some examples, that's actually exactly what it is. So here I have 5/9, and that's equal to 0.5 bar, because in 0.5 bar, you have 5 0.1 bars total. And since each 0.1 bar is 1/9, since you have 5 of them, that gives you 5/9. And the same concept applies to 99ths, 999ths, and so on. In this one, I have 0.14 bar, the bar above both the 1 and the 4. So since I have 14 different 0.01 bars in this, and that's how that works, then since each 0.01 bar equals 1/99th, then this should equal 14/99ths. And then this one, 0.1938 bar with the bar over all 4 numbers, should equal 1938 over 9,999. And that's exactly how this works. When you have repeating decimals with the bar over all of the numbers, then all you have to do is divide by that many 9s. So I have 4 decimals, so I divide by 4 nines, 9999. And that's why this is 1,938 over 9,999. But with repeating decimals, remember, you can have them over not all of the numbers. So next I have an example like this. 0.163 bar, except the bar is only over the 6 and the 3. And this one's a little bit different. This one equals 162 over 990, which also simplifies to 9 over 55. And that's why this one's a little bit more complicated, because when you don't have the bar over all the numbers, you can't just divide it by however many nines as decimals you have. You have to do something a little bit different, which is what I'm going to be teaching you now. So if you think about how you break up this fraction or this decimal, well, what it really is since the 1 doesn't repeat, it's 0.1 plus 0.63 or 0.063, sorry, with the bar above the 6 and the 3, because the 6 and the 3 is what repeats on forever, because it's 63, 63, 63, right? So 0.1 plus 0.063. Okay, well, this 0.1 you can easily convert into a fraction now, right? Because it's a terminating decimal. So this can be converted into 1 divided by 10 since it's in the tens place. Okay, so now you have 1 divided by 10. Now you're tasked with converting this one into a decimal. And I know that this bar still isn't over all the numbers, but trust me, I made it a little bit easier because what you can do is you can multiply this by 10. And just stick with me here. If I multiply 0.063 bar, the bar over the 6 and the 3 by 10, what that leaves me with is 0.63 bar. Because all you have to do is when you multiply any decimal by 10, all you do is you shift the decimal point over one place. And so let me give you another example. If I multiplied 9.48 by 10, what you do is you shift the decimal point over. And you can do this with any decimal. So the decimal point would be shifted one place this way when I multiply by 10. So this would actually give me 94.8. If I were to multiply 3.452 by 100, then since you're multiplying by 100, which is 2 tens, then you shift the decimal point over 2 places this way. So 1, 2, and so I put the decimal point here, and 3.452 times 100 is 345.2. And this concept still applies to repeating decimals. So if I were to multiply this repeating decimal by 10 to try and make it so the repeating decimal starts right after the decimal point, so the only decimals you have are repeating, then since I shift the decimal point in 0.063 over one value this way, then the decimal point is right in front of the 63, which means that if I multiply this by 10, you get 0.63 bar, which means that 0.063 bar equals 0.63 bar over 10. Well, now how does this help? Well, now you can just use the regular strategy you use by dividing by how many nines you have to convert this into a fraction, right? So since I have 2 different decimals here that are repeating, the 6 and the 3, then 0.63 bar equals 63 over 99. And then since it's divided by 10, well, what it really equals is 63 over 99, which is 0.63 bar, also over 10. And then if you simplify this fraction, what this really means is since you're dividing both by 99 and by 10, they're actually both in the denominator, and it's just divided by 99 times 10. And if you don't get this concept, then that's okay, because this is really, really complicated. It's probably the most complicated concept that we have in Arithmetic Me Too, and maybe all of Me Too. But what you do is you just have to make sure that you shift the decimal point, use this strategy here, like I did for these 3, and convert it into a decimal or into a fraction that way. So now my new fraction for 0.063 bar is 63 over 99 times 10. And 99 times 10 simplifies to 990. So over 990. All right, so now you still have to remember to add the 0.1, because I just converted this section into a decimal. I have to make sure to add the 0.1 that I have here, which is 1/10. So 0.163 bar, the bar over the 63, equals as a fraction 63 plus, or 63 over 990 plus 1 over 10. And then if you simplify these two fractions, you use whatever you do to add these fractions together, then what you get is 63 plus 100, or plus 99 over 990. So 63 over 990 plus 99 over 990. And that gives me 162 over 990. And then, like I said, this concept is really, really complicated. This one you should definitely know. If you have a repeating decimal with all the digits repeating, then you just divide it by however many nines you have as decimals. But when you don't have it, or when you have a repeating decimal with the bar not over all the numbers like I had in this example, the steps are you break it up into whatever parts you have that aren't repeating, and then the parts that are repeating. And then you change the parts that are repeating, like I did here, so that way you can shift the decimal point over by dividing or multiplying by 10. And then what you do is you normally convert that into a fraction and then add back together the parts that are repeating and the parts that aren't. All right, and lastly, I have a review question about converting a repeating decimal into a fraction. If you'd like to try it, I'll give you a few seconds to pause the video, and then I'll go ahead and explain the answer. So the correct answer to this question was 1 divided by 396, or 1/396. So in this question, I have a decimal that's repeating, right? But it doesn't have the bar over all the numbers, which means I can't use the normal way I would do it by just dividing by however many nines I have decimals. I have to convert it into a decimal that only has a bar over all of them, which means all of the decimals are part of the repeating part. So in order to do that, I have to think about what I have to multiply by. And if you remember when I explained how to do this, your first step was always to get rid of the sections that weren't repeating. But since I only have zeros that aren't repeating, I can't really get rid of these zeros here, right, by adding or subtracting anything, which means that all I have to do is somehow shift this decimal point over. So instead of 0.0025 bar with the 25 repeating, I just have 0.25 bar with the 25 repeating. And the 25 is the only part of the decimal. So what I have to do is I have to shift the decimal point over 2 places to the right in order to simplify this to a decimal that only has the decimals as repeating. All right, so the way that I do this, if you remember how to shift the decimal point, is I actually have to multiply by 100. So if I multiply 0.0025 bar by 100, so times 100, that's actually going to shift the decimal point over 2 places to the right and leave me with 0.25 bar, but the 25 is repeating, and now all my decimals I have as repeating. But remember, this is the decimal I'm trying to convert into a fraction, which means I need to make it so this equation reads 0.025 bar equals something, not times 100 equals something, but equals something. So I have to get rid of this 100. So naturally, I just divide by 100. Because if you think about it, 0.25 bar divided by 100 equals 0.0025. It's basically the opposite of multiplying this by 100. You just divide the other side by 100. So now I know that 0.25 bar divided by 100 equals 0.0025 bar. So now I can just convert the 0.25 bar into a fraction. And the way I do that is I just divide by however many nines as I have, or decimals as I have nines. So I have 2 decimals, so I divide by 2 nines, which is 99. So 0.25 bar equals 25 over 99. But remember, I'm still dividing this by 100, so I have to divide this by 100 as well in order to make it equal to 0.0025 bar. So if I divide it by 100, the way I do that is I multiply by 100 in the denominator, because it means I'm also dividing by 100, because whatever's in the denominator is what you're dividing by. So if I multiply by 100 in the denominator, that gives me 25 over 99 times 100, and that's going to be equal to 0.0025 bar. All right, so now if I simplify the denominator, that gives me 25 over 9,900. Now all I have left is to simplify this fraction. Well, I see that this fraction ends in 1 0, so I know it's divisible by 5. And it actually ends in 2 zeros, which means it's actually divisible by 25 as well, in case you didn't know that trick, because 25 is 5 times 5. So if I divide, I shouldn't have crossed these off because that's not how you simplify it. But so if I divide this 25 and 9,900 both by 25, then in the numerator I have 1, because 25 over 25 is 1. And then 9,900 divided by 25 equals 396. So if I put 396 in the denominator, then my remaining fraction of 0.0025 bar equals 1 over 396. All right, just to quickly review what we've learned this lesson, we learned what decimals are first, which is the other way of writing a portion of number aside from fractions. And then we had some examples that were here. And then we looked at exactly what decimals mean. In a decimal, you have a decimal point, which is the dot. Whatever comes after the decimal point is part of the decimal. And just like regular whole numbers have place values, decimals also have place values as well, where the first one is the tenths place, then the hundredths place, and the thousandth place, and so on. And so this would be 345 thousandths is what the decimal represents. And then we also broke decimals up into two categories, which are terminating decimals and repeating decimals. Terminating decimals are decimals that stop after a certain amount of decimals, and repeating decimals are the ones that just go on forever with a certain pattern. And then we also learned that when it comes to a bar over repeating decimals, which is how we signify that a number repeats, the only numbers that repeat are the ones that have the bar over it. So in these two examples, we have 0.34 bar, but they have the bar over different numbers, so which means they're completely different decimals when you actually look at what repeats. Next, we talked about how to convert fractions into decimals. And in order to do this, we just remember that a fraction really just represents another or one number divided by another number. So therefore, we just used long division and actually divided it to convert it into a decimal. And we learned that all you have to do is you have to add zeros onto the end of the long division question and add a decimal point in your answer when you start adding zeros. And so if you're left with a 0 after you subtract some numbers at the bottom of your long division, then you're finished and you have a terminating decimal, but you get a repeating decimal when you start repeating what you're dividing by in your question. And then we did a review question where we learned that 1/7 written as a decimal is 0.142857 bar. And then finally, we talked about decimal to fraction conversions. First, we learned how to convert terminating decimals into fractions, which was you just divide by the same amount of zeros as you have decimals with a 1 at the beginning. So for example, 0.345 would equal 345 divided by 1,000, since you have 3 decimals and 3 zeros. And that was terminating decimals. And then we also talked about repeating decimals, which had a different concept, where we learned that you have to divide by as many 9s as you have decimals. And then that only works though when you have decimals like these ones, where you have the bar over all of them. And then we learned a new strategy where it came to decimals where you don't have the bar over all the numbers, where what you have to do is get rid of the parts that aren't repeating and convert those into fractions separately. Then you have to move the decimal point over so all your decimals are repeating, convert that normally, and then add the fractions together, which was a really complicated subject, so it's okay if you had trouble understanding it, and I did my best to explain it. And then finally, we did a review question where we converted 0.0025 bar into a fraction, and we learned that was 1 over 396. All right, so that's it for this lesson. I'm sorry that a lot of this stuff was really, really complicated, especially with the repeating decimals into fractions. I know it also took me a little bit to understand exactly how that worked. I did my best to explain it, and I really hope it was helpful. I'll see you next time.